Cell phone charger. In today's mobile age, our cell phones keep us connected to everyone 24/7. Without these, we'll be back to the Stone Age. But irrespective of their class, they all run on a battery, which goes down at the end of the day. Have you ever wondered about that one thing that keeps your phone charging? Yes, we are talking about your cell phone charger. A mobile battery charger is a device that can automatically recharge a mobile phone's battery when the power and nets get slow. It basically converts high AC voltage to low usable DC output, which can be used to charge a mobile. So here you can see on the left side of the slide is an input, which is a sine wave, and on the right side of the slide is an output, which is a DC output, which we desire to get. Now let's have a look at how the stuff works. Here is the block diagram showing how the conversion is made. The AC input is first passed through a step-down transformer to lower the magnitude of the voltage. The rectifier converts the obtained output into a non-constant DC signal, and after passing it through the filter, the voltage becomes smooth. But this too contains ripple and can damage the load if applied across it. So, the output is finally passed through a regulator to generate a steady output signal. This output charges the mobile phone finally. Now let's talk about all this in a greater detail. Starting with the transformer. The transformer contains two huge copper coils. One between the two terminals of the input power supply, which is the primary coil, and the other between the two terminals of the output, which is the secondary coil. Because of oscillating AC voltage, there is a change in the magnetic flux inside the primary coil, which further changes the magnetic flux associated with the secondary coil. And as we all know, according to Faraday's law, an EMF is induced in the secondary coil. The number of loops in the secondary are less than that in the primary. So, in this case, the output is a step-down input. Now comes the rectifier. The rectifier converts the AC voltage output of the transformer to a DC voltage. But you can see here the circuit diagram of a full wave rectifier. It consists of a power diode connected to a single load resistance RL, with each diode taking in turn to supply current to the load. Then the point A of the transformer is positive with respect to point C. Diode D1 conducts in the forward direction as shown by the arrows. When in the negative half of the cycle, the point B is positive with respect to point C, diode D2 conducts. Since the current flowing through the resistor is same in both the cases, here is the output which we get. From the rectification stage, the output is DC but hardly constant, so we use capacitive filtering to smoothen the output. This is the circuit for capacitive filtering. During the positive cycle, the capacitor gets charged to its peak level, and while the input voltage is dropping, the capacitor sort of compensates for that voltage, and ultimately we get a less varying voltage curve. Now we come on to the voltage regulator. Here we use a Zener diode. As we know, in Zener diode, the voltage becomes constant after a particular value of current in reverse bias. Hence, a constant regulated output is obtained. In this slide, on the left side you can see the circuit of the Zener diode, whereas on the right side you can see a regulated output which is obtained, and this output is obtained across the load. And this is the final circuit diagram of a typical mobile charger which we all use.